Okay, so this is adding a node to a tree, this code here on our right hand side. We've got our 3 pointers, which are over here. These 3 pointers are like waiting to be used, and they're only limited in size. So I'll rephrase that, they are limited in the size, the amount. So in this case, let's imagine that we had 1, 2, 3, and 4 unused nodes in this free list. Our tree at the moment is empty. There's nothing in it at all. So it's a brand new one. And we're going to add an item to this binary tree. So we want to add something here. And that's what we want to do. To do that, we need to do a certain amount of code. The first thing we want to do is check to see if we've got any remaining nodes in our free list. So we go into our free list. Is this pointing to something, or is it pointing to null? If it's pointing to null, it's basically saying we've used everything. So game over. There's no free space left. But in our scenario, it's pointing to something. Great. So that means we do have some space. 4 spaces to be precise. What we're then going to do is we're going to assign our 3-pointer to be our new node pointer. So this would be pointing to 1 to begin with, not null, because it's 1. And we're going to basically put this value 1 into this variable. I'm going to put it down here, and I'm going to call it, I've never used this tool before, so new node pointer. Okay, you know what, that'll do. So that'll be 1. Then what we're going to do is we're going to get the data we're going to enter in. So let's imagine it was London, our data. So whenever we talk about new data item, oh crud. This tool is garbage. New data item. Yeah, new data item, and that is going to be London. So I'm just going to do L for London. So we're going to put that London into our tree, new node pointer, and its data side. So we've got a node. So new node pointer is going to be pointing towards this at the moment. And inside of it, we're going to put London. So we haven't actually put it into our tree yet, per se. So new node pointer is pointing to London. So that's what it would look like. So 1 is our first one. If this was being used already, so let's imagine we had 1 already in here. Then the 3-pointer would be pointing to 2, which would have changed the new node pointer to be 2, which means that we would have been pointing to the second node inside of this and put London in here, but that's not the case. So new node pointer, L for London. That's what this is doing here. We need to now change the 3-pointer, because no longer is this going to be the 3-pointer, because we're just about to use it. So what we want to do is change the 3-pointer so that it is pointing to the next node. And to do that, we take whatever's in the left-hand side. So remember, this would be pointing to 2, this would be pointing to 3, this would be pointing to 4. So we're going to take the number 2, and we're going to put this into the 3-pointer. So really, our 3-pointer now is pointing to this one. So notice we haven't put anything in the tree yet. All we've done is we've put in the next node in the free list, our data. We then pointed our new node pointer to our node which we're going to be using. We then adjusted the pointer for the 3-pointer. That's what we've done, if there are spaces remaining. So we've just done this bit. We then need to take this London. I'm just going to put it down here, which had originally 2. We've now got L in it, and we've got no. And what we're going to do is we're going to change this to also a no, or shall we say -1. It should be -1, not no. So that should be -1. All of these should be -1s. Keep that in mind. So -1. Why are we doing that? Well, here's the thing. When we put it into this tree, it will be pointing to nothing at the moment, because it's the most recent thing we've added. So imagine we did have something in there already. Let's say Manchester, and now we've just added London, which is what we're talking about down here. We're going to be adding London, but we'll say there's nothing after London, so that should be -1. Why do I keep doing no? That should be -1 in this case. That's what we're going to be intending to do. So we're getting ready for that. Now what we want to do is actually check this tree out, the current tree we've got. And we're going to first ask, is it empty? Is there nothing in it? If there's nothing in it, we can just put it in straight away. Really easy. So there's nothing in it. So let's imagine that we took out our Manchester. There's nothing in it. So all we have to do is point towards, I know this is going to get quite messy, this node, which would be 1. It's a new node pointer, which is this, will become our root pointer. Our 3 pointer will point to the 1 after it. But that's if it's empty. If it's not empty, so let's imagine we've got something in it like Manchester. So I'm just going to do M for Manchester. We need to find where we're going to put our London. So to begin with, we take the root pointer and we put it into a variable called index. So our root pointer would be -1. No. And we put it into index. That's if a tree isn't empty. If it is empty, we simply do this line of code here, where we put the new node pointer into root pointer. But if it's not empty, we first of all put this value of root pointer into index. We then run this function, so we're using a bit of recursion to find the insertion point. Actually, I say that back, it's not going to be recursion, it's just going to call this function. So that's the job of this. It's simply going to run this function to find the insertion point. And it'll be this function which will do all the work to find the place where it needs to go. So let me go through that again. The purpose of adding to tree is simply the following aspects. Step 1. Oops, didn't mean to do that. Can I zoom out? Come on. Do you know what I really hate about this? I have no idea what I'm doing. Is there a zoom out button on this? Let me pause. Okay, step 1 was to check to see if the free list was empty, as in if there's any free spaces left, or if it's full up, if it's all being used. In our scenario, we've got 4 spaces left. Brilliant. If it was all being used, we output a message saying there's no free space. But that's not the case. It's like having 4 substitutes in a football match. If we use all our substitutes, we've got no more substitutes left. So we say we can't make a sub. But because we do, we can make some substitutes. We can put it into our our main tree. So if it's not null, then what do? We have a variable called new node pointer, and that's going to temporarily store our current free pointer, so the first item in our free list. Remember, that could be used already. That could be used already in our binary tree 1 and 2, so that would be pointing to that. So whatever item it is. We then, once we've done that, adjust the node which we're going to be using. So in this case, it's this one. Sorry, no we don't. We then take a look at our new let me rewind that. Sorry, I'm half asleep. We've just done this bit here. So the next step is we're going to take the new data item and put it into the tree new node pointer data. So wherever we're going to put into our binary tree, we're going to put it into here. So L for London, for example. That's what that does. We then adjust the 3 pointer, because what we're going to do is we're going to say, okay, we're not going to be using this as our first available space because it's now being used, but we're going to take the next one. So we're not going to jump to the next one and increment it by 1. We're simply going to look at whatever is in the left pointer and put it into 3 pointer. So now we're pointing to number 2. So if we have to add another item in, that's our starting point. We then need to adjust our node so that it's -1. So we need to update this London. So our left pointer is pointing to null because it will be pointing to nothing. If we add whatever we add to the binary tree, let's say we've got Manchester in here. The next item will be London. L is less than M, so we go to the left of it. L, that is pointing to nothing after it. There's nothing. Oops, did that the wrong way out. There's nothing there. So no matter what, it's always going to be pointing to null to start off with if we add a new item. So that's always going to be the case. We then basically check to see this bit of code if we've got anything in our tree. So for example, if the root pointer is null, then we simply update the root pointer to be pointing to the item we just added, i.e. 1. If it isn't null, so let's imagine that we are pointing to 1. We then put our root pointer, which is 1, into a variable called index, which would equal 1. We then run this function, which will do the job of putting it in the right place for us in the tree by going left and right. And that is adding to the tree.